In this video, I want to talk about some ways to visualize effect size. So there's this great visualizer online at this website, Our Psychologist, which I'll put a link to in the description, that has a visualization of Cohen's D, so an interactive visualization. So what you can do is you can slide this slider here and it will show you in terms of two overlapping normal distributions what Cohen's D actually looks like. So if we have a Cohen's D of 0, we say we have a treatment and control group, that means there's no difference in the means of those distributions. Whereas if we have a Cohen's D of 1, that means we have a gap between these mean points of one standard deviation. And you can get a sense by playing with this, what each of these values mean that you see in education context. Often we're dealing in education with a Cohen's D of maybe around 0.3. So we can see here that, yes, there's a difference in the means, but there's still a lot of overlap and so forth. And what I like about this visualizer is down at the bottom, it has some of these ideas quantified, like this here, 88% overlap, meaning these distributions, 88% are overlapping. This one, the probability of superiority at 58% is saying if you randomly chose a person from the treatment group and a person from the control group, what's the probability that the person from the treatment group would be higher? And then this one, this idea of Cohen's U here is like saying 62% of the treatment group will be above the mean of the control group, which is that dotted line here. And as you play around, I'll make the window a little bigger here. As you play around with the slider, you can see how these things change. So if you have a Cohen's D of 0.01, or 0.1, excuse me, you have 96% overlap. Whereas if you have a Cohen's D, let's say you have a really gigantic Cohen's D of 2, which is extremely rare in education at least, if you randomly pick someone from the treatment group, there's a 92% chance that they would score higher than the control group. So I encourage you to play around with this, and you can get a more intuitive sense of what Cohen's D means. So I want to continue with another measure of effect size that we often see, which is Pearson's R, which is usually known as a correlation. And again, we have a great visualizer by the same author that allows us to visualize what a correlation looks like. The two most common reported effect sizes are Cohen's D, standardized mean difference, and correlation. So this one is pretty cool as well. You can change the sample size. You can get this over here would be like the R square, the proportion of variance in the outcome that's predicted by the independent variable. And then you can drag the slider to see how, the scatter plot would change when you have different correlations. So there's a correlation of 0.4. We see that's an R square of 16. And, we could go all the way up, to 1, and we have perfect prediction. And of course, with correlations, we can have negative associations. And another thing I like about this is that we can drag around points and see how the correlation changes in response to outliers, that sort of thing. So you can drag points around. And you can also change the sample size. And you may be wondering, like in Cohen's D, we have the means of just two groups. We don't actually have a continuous variable that's our predictor variable. We might just have like a treatment variable where it's 0 or 1. But the correlation can still tell us something there. So I'm just going to make a very simple example. I'm going to make a much smaller sample. And you can sort of imagine if you had the treatment students on one side, that's, the value of 1, and the control students on the other side at the value of 0, they're not exactly lined up. That's sort of what we're talking about. Imagine the y-axis are the test scores, and then here we have the control students, and here we have the treatment students. We can talk about correlations like that as well. So we could see, what might affect that correlation. Well, if we have a lot of overlap, just like those normal distributions we saw before, we see we have a much weaker correlation. Whereas if we have very low, variance within each group, you can get really, really high correlations, that sort of thing. So the correlation is going to depend on two things: the difference in the means, right? There's our y-axis, right? So this one's low, this one's high, and also the degree of variability. So let's say we have the same difference in the means, but we have much more variation. That's going to be a weaker correlation, just like Cohen's d. If the standard deviation is bigger, we're going to have a smaller Cohen's d. And if the difference in the means is smaller, we're going to have a smaller correlation as well. And we can get a sense of how that looks by playing around with some visualizations like this. So I encourage you to check these out and play with them on your own, and you will start to develop a much more intuitive understanding of what correlation and Cohen's d look like with data.